Yep.
Okay, good evening. We're here underneath some transmission lines out in the rural areas of Auglaize County, and we're going to do a little science experiment. And what we're going to do is demonstrate the amount of electricity that flows through some of our what are called transmission lines. Transmission lines take energy from the generation source and it takes it to a substation to where it can be distributed for communities. And the community that these particular transmission lines feeds are Chicago. So power is generated at a power plant down at the Ohio River, and it takes that energy all the way up to Chicago, probably 500 or 600 miles. Heck of a distance to travel. And in order to get there, you have to have a lot of voltage. And these lines are, like I said, some of the highest in the United States. There are 765,000 volts going through these lines. I'm sure some of you guys, if you're from the area, you're familiar with these lines because you can hear them when you stand underneath them. There's so much static electricity in the air. For our experiment, what we did, we took some light bulbs. These are just regular old T8 fluorescent light bulbs, and we stuck them in the ground. You can turn off that light now, babe. Maybe. Once we get the light off, we should be able to see the fluorescence of the tubes going.
I can see it.
Static electricity. You can see it?
Uh-huh.
All right. So we got the T8 tubes. They're in the ground, and they are lighting up because there's so much static electricity in the air coming off of the power lines overhead. And they're about 40 feet overhead or so. And they are, the top side of the terminals up here is the air, and then it's conducting through the ground, so it's making a circuit with the ground. Ooh, see that? Probably couldn't tell. There we go. So if we make better contact with the dirt, it'll actually light up more and then go away when I have poor contact. I've got an 8-foot tube here, a T8 tube also, that's really going to light up because it's able to get up a little closer to the static electricity of these lines. So I just hold my fingers on the terminal and she lights up pretty good. So if I bring it down and take my hands off, that phosphorescence goes away. So what's happening is the static electricity is a high voltage, and that high voltage also works to excite the gas particles inside of a fluorescent tube and to get them to excite and light up, which is basically what you do when you turn on the switch and turn on a fluorescent light. So this is pretty cool. I'll kind of back up so maybe we can get rid of that. Can you still see me?
I can still see it.
Okay. Pretty cool. I kind of feel like Luke Skywalker with this thing.
You have the name.
Yes, I do have the name. So that is it. So these lines here are so powerful that they cannot carry the energy on one cable. I'll show you some pictures, but there are 4 cables, and those 4 cables carries a 1 phase of current, and they act as a single conducter. The air between the cables is where the energy actually flows through. So there is a field that's probably 3 foot around in diameter where that electricity is flowing through the air. So that's why those cables they're parallel together, and they're bare. There's no insulation on those cables, and it's pretty cool. They'll have a guy come. They come and they check the lines about every 4 or 5 years, and they'll take helicopters, and there'll be a gentleman sitting on the side of the helicopter, and he will crawl on those lines on his hands and knees and go through and check all the connections. And they just did that last year, and my father and I come out and we watched the guys fly with the helicopters.